Okay, so today we're talking about apportionment methods. You guys, this has to do with back in the beginning of the United States when they were trying to determine how many seats of Congress each state gets. This became a big argument because you can't have a portion of a seat. You can't have a 0.5 of a seat for any state. So this was one of those things where they argued about what's the best way of granting the oddball seats that don't actually get a portion to other states. Okay. The other way that we would use this in real life is that, say you have a grandparent that might be being moved to a nursing home or something like that, or sadly pass away. Okay. Then they have all their stuff that needs to be divvied out to the kids. And if any of you guys have ever lived through that kind of a process, it can be really ugly if there is not a plan involved. So what happens is, if you use an apportionment method, then it's very fair. It's understood before things are given out, and then there won't be so many arguments. So it'd be a lot more peaceful situation. So you guys will, at one point in your life, have to deal with apportionment, whether it's through dealing with election processes or through having to divvy up things. So, or say like you won a lotto. How do you decide what each of your kids get or if they get anything at all? So it's kind of one of those things. Okay, so that's what we're talking about with apportionment. So here we have an example, and we're going to use this example throughout today's lesson. We have a small country that's comprised of 4 states, A, B, C, and D. The population of each state is in the 1,000 and is given by the following table. Here, A has 138, B has 266, C has 534, and D has 662, with a total population in the entire country of 1,600. All right? So according to the country's constitution, the Congress will have 80 seats. There's only 80 to be used. Right here. Okay? So 80 seats is what we have, divided among 4 states according to the respective populations. So one of the first things that we want to do is look at what is called a standard divisor. To find that, you're going to take the total population and divide it by the number of items to be allocated. In this case, we have a total population of 1,600. So we're going to take 1,600 and divide it by the total seats that we have. That's 80. So our standard divisor in this case, and we're going to call that little d, is going to be 20. So next I want to ask you guys, how many people are there for each seat in Congress in this particular case? How much?
20,000?
Yeah, it's going to be 20. Yep. Because remember, this is in the thousands. Yep. Yep. So the allocated items to be allocated were the 80 seats of Congress, right? Okay, it's the things that we're divvying up between the states. So 20,000 people per seat. Okay. So the next question we have for you guys is to find each state's standard quota. What a standard quota is the following. A standard quota is the population or of a particular group divided by the standard divisor. I can think of another way that you guys might be familiar with this sort of thing is, remember we had a state hockey game this year. And how did they allocate the number of seats per grade level? It was a lottery, but I have a feeling that also seniors had a little bit more space than the juniors and the sophomores based on ranking, right? So there was a process planned on how many seats per grade level, and that would be an allocation that you guys would have experienced. Okay. So we want to look at the standard quota for each state now. So we have up above, we had, and actually we'll use the one below here. It says standard quota. What you're going to do for A, this is the total population for state A is 138. You're going to take 138 and divide it by 20. So if you take 138 divided by 20, you're going to end up with 6.9. Okay? 20. 138, this number, divided by 20, which happens to be our D, our standard divisor that we found earlier on the page. Okay? And that ends up being 6.9. So 266 divided by 20 is 13.3. 534 divided by 20 is 26.7. And then 662 divided by 20 is 33.1. Okay, so as you guys can see, we have an issue here, and that issue is you can't have a 0.9 or a 0.3 of a seat. Can't divide up people like that, or seats, okay? So there are two things we can look at. We can look at lower quota, and that's taking these numbers and rounding them down. Okay, so I'm going to find my lower quota. It is 6.9 is going to be a 6 now. You're rounding down. So 13.3 will be 13. 26.7 will be 26. 33.1 will be 33. If you add all those together, your total will now be 78. So when we do the lower quota for looking at this, we have 2 seats that are extra just floating there with no one allocated to them, okay? Okay, so for upper quota, instead of rounding down, we're going to round up, okay? So rounding up, we have 6.9 goes to a 7, 13.3 goes to 14, 26 goes to 27, 33 goes to 34. And if you round up, you end up with 82. That means we have actually in use 2 more seats than we actually have. Okay, this is the next page. And the first method that we're looking at was developed by Hamilton, okay? One of our forefathers. And we're going to also do one about Jefferson today. And then tomorrow we'll do 2 other ones. But one thing I want to tell you guys is that we are limited by time on examining all the different methods for doing this. And if you were to talk to Mr. Bolstead about this, he would tell you that these 4 methods, he doesn't find any of them fair. There's other ways of doing it. So he's a little bit ahead of us, and he's actually having his class do a couple different other methods as well. So if you're interested, you could ask somebody from his class or ask Mr. Bolstead about that, okay? Or Google it, apportionment methods, okay? But basically, Hamilton's method, what they do to start off is to calculate each group's standard quota, just like what we did. Okay? The second step is they actually go find the lower quota. Okay? So initially, each group gets the lower quota. Then, whatever is surplus, whatever's extra, they are divvied up for each state with the largest decimal on their standard quota. So I'm going to show you how to do that with this. Okay, first of all, our standard quota is this. We already found that on the page before, and our lower quota is this. We have how many less seats than the total? 2. So we have 2 extra seats that we need to divvy up. So our next step is to look at the decimal points in the standard quota. We have a 6.9, a 0.3, a 0.7, and a 0.1. So which one has the largest decimal point? A. A has the largest decimal point, so they're going to be the one that gets to go up a seat. So instead of 6, they're going to have 7. Now, which is the next one with the largest decimal point? C. So C, instead of 26, they're going to get 27. The other two are going to stay at their lower quota. So this will be 13, and this one will be 33. And if you add that up, that's a total of 80 seats now. So that is how you do Hamilton's method. Okay, so one important rule that you guys need to know is called the quota rule. The group's apportionment should be either its upper quota or its lower quota. An apportionment method that guarantees that this will always occur is said to satisfy the quota rule. So in other words, if you look back at this, A is at 7, that's its upper quota. It doesn't go above that. B is 13, that's a lower quota. C is at 27, D is at 33. So notice that they're staying within the bounds of the quotas. Okay, they don't go outside of that. And that's important for the rules of this, okay? Yeah. Okay, so now let's look at Jefferson's method. Okay, so on Jefferson's method, you need to find a modified divisor, D. What we were using before was the standard divisor, right, where we took the total population and divided by allocated parts. Now, it is rounded such that the group's modified quota is rounded down to the nearest whole number. The sum of the whole numbers for each of the groups is the number of the items to be apportioned. The modified quotients that are rounded down are called modified lower quotas. Apportioned to each group is modified lower quota. In other words, what's happening here is we're not using the standard quota. We're not using the standard divisor. We're making up one, and we're going to guess and check to find it. So what I want you guys to write is in this note, there is no formula for finding Jefferson's divisor. Okay? You are using trial and error to find it. Okay? So typically, this divisor is slightly less than the standard divisor. Okay, earlier we found that the standard divisor was 20, so we need to find something slightly less than 20. So let's try, first of all, using a divisor of 19. Okay, so I'm going to have A, B, C, and D here, starting off with the populations of 138, 266, 534, and 1662. What we need to do is try to get this to equal 80. We need them to equal 80. So we're going to take 138 and divide it by 19. So our modified quota ends up being 7.26 because I'm dividing each one by 19 this time. Okay, the second one is 266 divided by 19. You actually get 14. 534 divided by 19 is 28.1. And 662 divided by 19 is 34.8. Okay, so if we go to the lower quota now from based on these numbers, our lower quota for this is what? 7, 14, 28, and 34. If you add all that up, it equals 83. It does not equal 80, so that is not a good divisor. So guess what we get to do?
Hold on, so do you always round down?
For this one, for Jefferson, you round down.
What for
Hamilton,
Hamilton?
you round, yeah. Okay. So now let's try a different number. Try 19.5. Okay. So if you try 19.5, I'm just going to keep going here with this. We'll have a modified quota. So if we divide everything by 19.5, we get 7.08.
You want to use a lower number?
No.
Higher than 80?
No, because we want it to be closer to 80. This is higher than 80, so you have to use actually a higher number. Because you want, yeah, you're dividing. Okay, so this will be 13.64, 27.38, and then 33.94. So now if the lower quota in this case will be 7, 13, 27, and 33. If you add all that up, it equals 80. So we finally found the correct one. You just, it's guess and check. It's totally guess and check in this case. So I tried at 19. 19 didn't work, so I went to the next half number. Okay?
Well, why'd you do it?